Hey everyone, welcome back to another quick one. Been posting a lot lately. This is just another devlog, I guess. It's really more of a question or a problem I'm trying to solve, so this isn't really educational, but if you know about scanning white light interferometers and their software, maybe you can help me out here. So I'm trying to make this into an actual functional measuring instrument, and the way I'm doing that is the method where you have your sample here, and we're moving the reference arm here, and we focus on the sample and then sweep the reference arm at a very slow, very constant, consistent speed, basically starting on one side of 0 path length difference between the two arms and then going to the other side. So all the way from no fringes to no fringes again. So we get this sort of little chirp of interference because the coherence length is low. This is actually a sneak peek what that looks like here. This is the cleanest one I was able to get. I was really pleased with how this looks. It's got an envelope function surrounding it. And so what we do is, because we're moving at a constant speed, this is the frames down here on the x-axis, but each of those frames can just be converted to displacement value since we're moving at a constant speed through these frames. So we take the envelope for each pixel. This is just for one pixel, right, in the time domain. Find basically the peak of that envelope and say, okay, that pixel gets associated with the height value that's associated with 400 pixels. We do that for all the pixels. Humongously computationally intensive. It takes, even with very low res videos that I'm using here, it takes like at least a minute to run this code. But then we get a height map for the whole image. So the problem I'm having is the resulting data ends up looking really noisy. This is really clean. This is, let me show you the actual like raw video here. This is just the two glass discs that I showed in before. So no high frequency roughness, just a nice smooth glass, and see the fringes going through there. And this is the video that gets processed in MATLAB. And when you run it through all that stuff, this is just for one pixel, but then you do that for all pixels, and this is what I got. So this is looking at it from the top here. I don't know what these ridges are in it. That could be real, that could be an artifact, I'm not quite sure. But you notice when I look at it from the side, ton of noise. And this z-axis here, this should be in microns, and I believe that is accurate. So, you know, that's obviously, that's not representative of what we're really seeing on the block. I don't know what could be causing all that noise there. It gets even worse if we look at, for example, the Moore block. So this is an actual ground surface. Here's the raw video. Obviously, because there's a lot of high spatial frequency roughness, you can't see nice fringes moving across the whole thing, but you know, I got the job done. The contrast wasn't quite as good, but sort of worked. And then yeah, this is the output from that. So it looks, yeah, not great. You can see still like a couple microns peak to peak of noise there. And it did get some of the features, like, I guess it's spun, but like those little dents there are those dents there. So it did pick those up. But there's some, I'm guessing I don't know if it's something with my my real life setup or my processing that's making all that noise in the result. I know one thing that needs to be addressed is the lighting. So this image here that we're looking at on the microscope, this is good for if we wanted to use this as a visual microscope, but because we've got lots of nice contrast and we can see all the scratches and everything. But it's actually kind of terrible for the white light interferometry because we're not getting light down into these cracks that we'd like to inspect. So you'll notice as the fringes come across, there's no intensity modulation happening in these valleys, these basically unlit areas. And if there's no intensity modulation from interference, then we can't see them in the final result. Those, when you take the envelope and find the peak, I mean, it will just basically get a random value for all those pixels in there. So not ideal. I need to upgrade the lighting, but I don't know if that accounts for all of it. Maybe it's vibration. Maybe there's another processing technique that would be better than this method entirely. I don't know. So if you got any ideas, let me know. Oh yeah, I did. Just for fun. Did process these guys. These look familiar. These are actually from Huygens Optics video on the white light interferometers, which is the best explanation out there, bar none. So this is that spherical mirror he did, and then this is that etched glass sample. And it's working to the extent where this is clearly a spherical shape, and you can see the steps and the steps and the features and stuff. But yeah, don't know what's going on with the noise there. Anyways, let me know if you know or have any ideas. Cheers.